I welcome you to my YouTube channel MakePM. So in today's video, we will try to find a stress and a strain in the compound strut or type. So you can see there is a tube and it is surrounding a rod. Okay, this is a rod and the tube is surrounding it. So this is one type of composite structure. So how to calculate the combined stress and how to calculate the combined load carrying capacity of this strut or type. So first let's read the what is written. Frequently ties consist of two materials. You can see that if you are making a beam or column of the concrete, then we put inside the metal bars to make it stronger. So how do we calculate the load carrying capacity in those cases? So you can see from here that if load P is applied here, then some load will be carried by this section, some load will be carried by this section. So load P is equal to sigma 1 A1 plus sigma 2 A2, means stress in this tube into area of the cross sectional area of the tube plus stress in this second material into area of this. Okay, and strain, how much will be the strain? As you know that when load P will be applied, then this will try to elongate. Suppose this is getting elongated up to here, then these two things, even if one is stronger and one is weaker, these two will elongate together because these two are holding each other. So in that case, strain in one is equal to strain in two. So what is the formula for strain? Strain is equal to stress upon E. So for this we will have sigma 1 E1 is equal to sigma 1 upon sigma 2 is equal to E1 upon E2 from here. Sigma 1 upon E1 is equal to sigma 2 upon E2, or sigma 1 stress in 1 upon stress in 2 is equal to will be equal to ratio of their modulus of elasticity. Now we will try to solve this problem. A concrete column of cross-sectional area 400 into 400 mm, this is 400 length, 400 mm is height also, is reinforced by 4 longitudinal 50 mm diameter round steel bars. So these are 4 steel bars which are reinforced with concrete with diameter of 50 mm. If the column carries a compressive load of 300 kN, P is 300 kN. Determine loads carried. So we have to calculate the loads carried by concrete and loads carried by the steel bars. The compressive stress produced in the concrete and steel bars, and we have to also calculate the compressive stress produced in these two, sigma C and sigma S. Young's modulus of elasticity of steel is 15 times. So E for steel is 15 times EC. Okay, so first of all we will calculate the area. Total area is 400. This is 400 mm, so it will be 0.4 meter. So 0.4 into 0.4 is equal to 0.16 meter square. Now area of steel bars is, there are 4 steel bars, so 4 into pi by 4 into d square. So d diameter is 50 mm, 0.05. So area will be, area of steel is equal to 0.00785 meter square. Now area of concrete is equal to total area 80 minus area of steel. So it is equal to 0.16 minus 0.00785. So it will be equal to 0.00785 area of concrete will be equal to 0.1521 meter square. Now we are applying load on this structure or column. So these are enforced together, so deformity in these two will be same. I mean strain in the steel bar and strain in the concrete bar will be same. So E steel is equal to E concrete, means strain in steel bar and strain in concrete bar will be same. So E can be, strain can be written as sigma divided by E. So sigma S upon ES is equal to sigma C upon EC. So from here we can write sigma S is equal to sigma C into ES upon EC. Now we know that ES upon EC is 15. See here, steel, Young's model of elastic steel is 15 times that of concrete. So it will become sigma C into 15, or we can write as sigma of steel is equal to stress carried by steel is equal to 15 times stress carried by concrete. So this is our one relation we have find out. Now we have seen that total load carried out by this structure is, or beam is 300 kilonewton. Total compressive load is 300 kilonewton. Okay, so load on steel plus load on concrete is equal to 300 kilonewton, which will be equal to 3 lakh Newton. Now load is equal to, as we know, force is equal to stress into area. So PS will be sigma S stress on steel into area of steel plus stress on concrete into area of concrete is equal to 3 lakh Newton. Now sigma S into S, sigma S is already 15 sigma C from here. So 15 sigma C into area of steel is, we have calculated area of steel, which is 0.00785 meter square plus sigma C into AC is 0.1521 meter square is equal to 3 lakh. Now sigma C will be common, 15 into 0.00785 plus 0.1521 is equal to 3 lakh. Now sigma C, if you calculate from here, then it will be 3 lakh divided by this amount. So it will come 1.11 into 10 to the power 6 Newton per meter square, or 1.11 10 to the power 6 is mega Newton. So it is mega Newton per meter square. This is value of sigma C, stress of in concrete. So stress in steel is equal to 15 sigma C. We already calculated in equation 1 here. So it will be 15 into 1.11 into, or just we can write in terms of mega Newton. So it will be equal to 16.65 mega Newton per meter square. So this is stress we have calculated in steel and in concrete. So we will calculate load. Load on steel will be stress in steel into area of steel, which will be equal to 16.65 into 10 to the power 6 into area of steel was 0.00785. So if you multiply this, then you will get 130.7 kilo Newton. So this is the load carried by steel. Now load carried by concrete will be equal to 1.11, which will equal to sigma concrete into area of concrete, which will be equal to 1.11 mega Newton per meter square. So it is 10 to the power 6 into area is 0.1521, which will be equal to 168.9 kilo Newton. So we have calculated the load carried by these two components, steel and concrete, and we have also calculated the stress on these two. So I hope you understood this problem. If you have any doubt, then please ask in the comment section. And if you like this video, then please share and subscribe. Thanks for watching this video.